So there's a couple functions that do math things, but they still take in a storage just to keep this consistent API. That's technically less performant than making the API be the scoreboard, but it's more readable, it's more coherent with the entire library.
Hello everyone. Welcome back. I'm Gears.
And I'm Mox Valix. And welcome to the Datapack podcast. Episode 8, is it?
Episode 8. That is correct. So, today we are going to be talking about premature optimization, which is a term which is not just relevant to Datapacks, it's also relevant to all programming, really. This applies to pretty much whatever language you're programming in. But before we actually get started on what premature optimization is, I'll just explain that we're doing this setup. We're trying something new this time. Instead of recording Minecraft and the podcast audio at the same time, like we've done for the past 7 episodes, we found that when we were doing that, our attention was sort of split between playing Minecraft and recording the podcast. So when we were playing Minecraft, we weren't properly focusing on the podcast and we were sort of stumbling through our words a lot. And, you know, I know that can be frustrating for people, especially if they're listening to audio only without the video. And then also when we were talking about stuff, we couldn't focus on the Minecraft gameplay, and so we didn't progress very far, as you'll probably notice in the video. So today we are trying something different. We've already recorded the Minecraft gameplay separately, and now we're just in a voice call in Discord talking about stuff, and then we'll splice them together for the video version later, and we'll see how that goes. Hopefully it will improve the quality significantly.
Yeah.
Anyway, premature optimization. We all know what optimization is, and I do want to cover optimization because not all optimization is premature optimization, but optimization is where you take something which isn't functioning optimally. In the case of programming, that's often that it's running slowly or not quite efficiently in the way you want it to, and you make it better, you make it more efficient, you make it faster, etc. And this is very useful because, as we all know, Datapacks aren't particularly fast. They're not made for running programs very quickly like a CPU is, right? So when you write a program in a different programming language, it's often, it's either compiled to machine code which runs directly on your CPU, or it is interpreted by something else which is already compiled to machine code. And so a lot of the time, unless you have a really big thing which is crunching a lot of data or doing a lot of calculations, you barely notice the speed because it's milliseconds. It's faster than you can even perceive. But with Datapacks, you can notice a significant decrease in performance if you don't do everything correctly. And so I think there's this mentality in the Datapack community, which is that everything has to be done in the most optimized and efficient way. And that is pretty much the spirit of premature optimization. Premature optimization, as the name suggests, is optimizing something before it needs to be optimized. So let's say, here's an example, a real-world example. Facebook, right? Facebook is a massive platform which has millions of users. I don't know the exact number, but it has to handle a lot of data every day, every hour, every minute, every second. And so the code which runs Facebook needs to be pretty fast, right, to handle all that data. But when Facebook was first being written, did Mark Zuckerberg originally code Facebook himself? I don't remember exactly, but anyway.
I don't know how much of the actual coding he did, but yeah. I think he did some, maybe.
Anyway, it was originally written in PHP, famously a not great language, and it's probably not the fastest either. But that didn't matter because at the time, he had no idea that Facebook was going to become the huge social media platform that it did. He just was making a little website for whatever the original purpose was, and it didn't need to be fast. So all he did was write it in PHP, and then as it started to grow, they started to rewrite it in whatever language it's written in now. I don't actually know. And they optimized it when they needed to. They didn't optimize it prematurely. What would have been premature optimization is envisioning one day this is going to have millions of users, so I have to do everything exactly as efficiently as possible and not waste a single kilobyte of memory, or, do everything, write it in a compiled language which runs at native speeds and blah, blah, blah. That wasn't necessary, really, right?
Well, you don't know if your thing's going to take off. You don't know if you're going to ever have millions and millions of users.
Yeah, exactly. And so if it didn't, there's not really any point in writing it fast, because there's no need for it to be that fast.
And usually as well, it takes time to optimize things, and that's time that could be used to grow your program or whatever you've made in other ways. So if you spend all your resources optimizing it to have millions of users, you might not even end up with millions of users because you spend all your time optimizing it.
Yeah, for sure. So anyway, let me bring this back to Datapacks. And I think there's this mentality in the Datapack community. Not everyone has it, obviously, but I think a lot of people feel that everything needs to be done in the most optimal and efficient way. And I think there's a lot of work put into benchmarking various commands against each other and testing which solution is more performant and stuff like that, which has its merit. When you have a big data pack which does a lot of complex things, you don't want it to take a significant portion of the resources of the server that's running it. You do want it to be fast and optimized. But I think people do a lot of premature optimization. So let me talk about for a minute a server that we're both in called Datapack Hub, which is a server for, discussing data packs, and it also has a big focus on help channels, which are where beginners or any data packer who doesn't know how to do something can ask the community for help, and people will come and help them with their problem, which is great. It's very helpful. I've asked a few times, and I've helped a lot of people, and it's good fun and it's enjoyable to take part in. But one thing that I've seen is sometimes a beginner will ask a question. So, how do I do this specific thing? And somebody will respond saying, okay, well, here's how you could do it. And then, they'll give a solution. And not always, but I've seen quite a few times the beginner will then say, how optimized is that? Because I don't want to make it too slow or whatever. And I think there's this aversion to running commands every tick. Some people try to avoid at all costs putting anything in the tick function, because you've got to run stuff every tick. And there is some, you don't want to be putting at ease all over your tick function, right? Because that's not good. You should do some optimization, but you shouldn't worry about the exact details to which every single command is, make sure it's doing the exact correct thing. The way I like to program in Datapacks and in any other language is first, just get it working. You want to do something? I don't care how you get it done, just get it working some way. And then take a look back at your implementation and refine it, whether that's redoing it to make it a bit more readable and understandable what it's doing. That happens. Sometimes I do it and I realize afterwards that's a bit of a convoluted way of doing it. I could do it in this much more straightforward way, and then if I read back on it later, I'll be able to understand my reasoning behind the certain things. Or maybe you realize, oh, I'm doing all this stuff when actually that's really unnecessary, and that will maybe slow the program down, and then you can trim it back. But most of the time I don't actually go through and optimize things for speed, apart from if I actually need to. So I think this would be a good time to bring up Code of Copper, right? Because we, as everyone listening is probably painfully aware by now, we initially made Code of Copper in 1 week. And in 1 week, you don't have the time to focus on making everything as efficient as possible because you need to spend your time developing the features which you want to get done before the week's up, because you're very limited on time. So if you spend all your time, optimizing your data pack, then as you said, you're not going to get any of the features down, because by the time you've finished optimizing the first feature you've added, you don't have any time for the rest. So the initial version of the pack was very much hacked together, and it was just what works. Does this work? Yes. Okay, I'm just going to move on, and if I have time, I'll come back later, but I don't have that much time, so I'm just going to leave it. The saying, if it ain't broke, don't fix it. That's true in some cases. It's not applicable to every situation, obviously. I think you probably remember, probably 2 or 3 releases down the line, we started to notice that if you had more than 2 or 3 golems running at the same time, it would significantly have an impact on performance. And it was at that point which we decided, okay, let's take a look. We're gonna do a debug profiling or whatever, which is something built into Minecraft, and you press a hotkey and it does this thing for however long, and then you can use Misode. They have a very nice tool for analyzing your debug reports, and they tell you all the commands which are running and how much time they're taking up. And it was then we realized that all our data merge commands were doing, for some reason, I don't know why data merge is so inefficient, but they were taking way more time than everything else. And so we replaced all our data merge commands with data modify commands, and that improved the performance by quite a lot. And it's just because we have so many iterating processes, because we're running the same commands over and over and over again, that this tiny little difference between a modify versus a merge creates a massive amount of difference in the grand scheme of things, I guess. Yeah, it stacks up. Also, when you're optimizing, you have to take into account how often something runs, right? Which is why in Golem script again, the interpreter runs instructions over multiple ticks, because if it tried to run everything in one tick, it would hit the command limit or cause a lot of lag in one go, and you'd be doing that quite often. Whereas the parser, since it only runs once per program that you want to parse, we didn't bother optimizing as much because it only runs once. It's a little lag spike maybe, and then nothing. But the interpreter runs continuously, right?
Yeah, I would say the parser's optimized for a different metric, where the interpreter's more optimized for actual performance, TPS, which is ticks per second. The parser is optimized to run in the least amount of lines possible. So it will do some more expensive operations like a data merge instead of a data modify in order to save on a couple of lines, because those couple of lines add up to hundreds and hundreds of lines to your line count, which you could then go over command limit, which we didn't really want.
Yeah, and I remember because in the beginning, with the default command limit, which is 65,536, the parser could only parse about 1 page of code. Maybe it was 2 or 3 actually, but it couldn't do very many, and it would hit the command limit. So we had to actually increase the command limit to about 1 million, and that way it can parse pretty much as long a program
anything you throw at it.
Yeah.
Although it might be worth trying to figure out what the longest program we want to support is, and maybe lowering the command limit that we've got a bit. We
could technically split, if we wanted to, we could split it up and parse, I don't know, 1 page. Actually, would that work? Would the parser work over multiple ticks? I guess since it has
the parser's not
stack,
built to do that. It could theoretically, but it would need a bit of work to do that.
Because then, we could technically lower the command limit and have it take a couple of ticks to parse. I don't know if that's something we want to do. Anyway, that's for a separate conversation. But yeah, initially, Code of Copper wasn't particularly well optimized because of the time constraints and just because we didn't think about it. When I'm making a datapack, optimization is not the first thing I'm thinking about. The first thing I'm thinking about is this going to be an enjoyable experience for the person who's using it? Does this fulfill the idea that I have in mind? Is this going to work how I want it to? What solution can I find using Datapacks and their hacky workarounds that works for the problem I'm currently facing? I'm not thinking about how many milliseconds is this command going to take to run most of the time.
Yeah.
Yeah.
But on the other side as well, I mean, like, as I've learned Datapacks, as I've worked with Datapacks more, naturally I've just started, like, almost optimizing them without really thinking. Like, I know patterns that are more optimized for making Datapacks, so I've started using that, and they don't take that much extra time, and it's not like... It's different to Premature Optimization, I think. It's like if you've learnt a pattern that you know is it works. Like for example, if you've got a bunch of markers and block displays and stuff like that are going to be doing a bunch of stuff. A pattern I've learned to do is like make an entity tag, put those entity types in the entity tag, and then have in your tick run an @e as all of those. And then you can like branch out from there as to what logic it should be in the sub functions. And that's just a practice I've started doing. And it's like, it's not really like I've stopped everything to optimize that. I just have learned that that's a thing you could do, right? And just start doing it.
Yeah, I agree. So definitely now, not that I ever used data merge before. For some reason, I never used data merge. I always used data modify, not for any optimization reasons, just for... I'm not sure exactly why, but that's just the way I programmed. Everyone codes in a different style, right? But now that we realize that data merge commands are so much slower than data modify commands from Code of Copper, now I just won't use them, really, unless there's some specific reason why I do need to, but I guess the only reason is if you want to merge two objects together, two compounds. But if you just want to merge a predetermined set of keys, it's probably just better to use data modify, unless you're doing like hundreds of keys or something, which is unlikely, I think. But yeah, so now I just know it doesn't take a lot of conscious effort not to use data merge and just use data modify instead. So yeah, I think there is some validity to knowing some optimization tricks, knowing which versions of commands are more efficient than others, knowing that MBT operations are always more expensive than scoreboard operations, and stuff like that. But I think there's definitely there's too much emphasis put on optimization, and I think some people take it a little more seriously than maybe they should, and go to extremes, and I don't know, for small performance increases, do a whole refactor. Instead of just writing a command in tick, you get an advancement and a predicate and a blah blah blah, and you just chain it all together, and it's just not worth it all of the time. So yeah, it's something to think about. But also, there is a time and a place for optimization. So, if you're just making a little pack for you to play on in your single-player world or with your friends or whatever, unless you actually notice an impact in your specific use case, don't bother optimizing it beyond just whatever comes naturally, like using data modify instead of data merge. It's just not worth it. But if you're releasing a pack to the internet, and especially if, well, obviously you can't tell how popular a pack's going to be, but you can sort of make an educated guess. If you've posted a lot of data packs before and you get a lot of downloads on them, then you can make an educated guess that you're probably going to get quite a lot of people playing it, and in that case you might want to look into optimizing it. But before you look into optimizing it, what I sometimes do is I just play with the pack a bit, and I just take a look at the TPS graph on the bottom right of the F3 screen. I think F3.2 brings it up. And I just see, is this any higher than it would usually be if I weren't playing with this datapack? And if it's barely noticeable, if you can't even tell that the datapack is changing, is affecting performance, don't bother, right? Don't bother making everything as efficient as possible, because one data merge command running once on world load instead of 2 data modify commands is going to make zero impact on anything at all, right? That's just worth noting. And yeah, again, think how many times things are going to run. If you're doing stuff on load, that's pretty much before anyone even joins the world, so they won't notice the world taking an extra second to load, right? If you're doing stuff once when a player joins, don't bother.
So you've got to be doing some pretty interesting things to take an extra second, though.
Yeah, I mean,
that's a lot of commands.
For sure. Yeah, exactly. It wouldn't even be that much. But if you're running something every tick, you don't want to have execute as at e several times in your tick function, because that probably will, depending on what you're doing, but almost definitely that will impact performance some amount. So, yeah, I mean, in a second we can maybe talk about some general techniques for people who want to learn about optimization techniques, or just simple things you can do which improve performance and stuff, and also sometimes make your code easier to read. I was going to say one more thing, which is that libraries, right? So when we were, obviously you've written a library called moxlib, which we used in Code of Copper and pretty much all our projects together, and it's very useful and has a lot of useful functions. And at one point I started adding some things to it, and at that point I was conscious of optimization, because when you're writing a library, I mean, it depends on what the library is, right? If you know that a certain thing's only going to be run in a certain context, maybe don't bother optimizing it too much. But with something like moxlib, which has a lot of low-level functions, which are it has a lot of low-level functions which are often in other programming languages, and they're just sort of general utilities, things like splitting a string into an array of characters, or reversing an array, or stuff like that, right? And you can't know in what context somebody is going to use those functions. They might be using them, as in, Code of Copper, we use moxlib quite often. In fact, I think the interpreter uses moxlib every tick several times, because it's got to look up the current command in the registry, and a lot of that is solved now with macros, so you don't necessarily need moxlib for a lot of that. But before then, you can't tell what context or how often those things are being used, and so you should optimize libraries as much as possible, to an extent. You don't want to, again, it depends on the library, but you want them to be pretty fast so that people don't need to worry about, oh no, now I have to call out to moxlib and that's not good because that gives a huge performance hit. You want it to be, oh, I'm going to call out to moxlib and that's not a whole lot of commands, so I don't need to worry about that, right? And one thing that I've seen, which is sort of similar, which is when I've sometimes, for whatever reason, when I'm coding in a different language, for example Rust or Go, or often these compiled languages, for whatever reason I'm using a function like split a string by a certain character, so every occurrence of the character splits into a new thing, or I don't know, sorting an array or whatever. Sometimes I'm just get curious and I control-click in the editor, which takes me to the definition of that function where the people who have made the programming language have written that code, and I just take a peek through how they've implemented it, and a lot of the time it's pretty esoteric and there's weird things going on, and calling out to functions which do little and it's hard to understand, but that's because the standard library isn't meant to be for people to read through and go back and change later. It's meant to be as efficient as possible, because you don't want to have to think about calling out to the standard library and thinking of that as that's going to give a huge performance hit. And so I think in certain libraries, especially low-level ones which could be called very often, it is definitely useful to optimize. But if you have a library for creating custom blocks, let's say, and you want to create a code which registers a custom block, so each datapack will call that function on load and say, here are all the blocks which I have defined, please do your magic with those. You don't need to worry too much about that, because that's pretty much only going to be called once on world load. But you would probably want to optimize the functions which run at the blocks every tick to do the checks to see if they had been broken or whatever, because those would be run pretty often on tick probably. It really, optimization is all dependent on context, right? If it's a standalone pack, just take a look, see is this causing any performance difference. If not, don't bother. If it is, then maybe take a look into it. And if it's a library, then it's probably more worth it to do that, because you don't know what use cases people are going to be using it for, and you don't want to cause anybody else trouble because of your code that you've written.
Yeah. And I'll say another thing is that sometimes not optimizing something is a choice that you make, because maybe there are other benefits to the way that it's implemented. For example, like storage in Minecraft Datapacks is less efficient than scoreboard. That's something that's been it's a known optimization thing.
Yeah.
But sometimes using the storage is a lot nicer and a lot more readable than using the scoreboard. And so a lot of moxlib functions will, like, moxlib's basically got an API where it you write to a storage and then run the function, and that's how you give the inputs, and then the function will write to that same storage in an output section, and that's how you get the outputs, right? So there's a couple functions that do math things, but they still take in a storage just to keep this consistent, like, API. And that's technically less performant than making, the API be the scoreboard, but it's more readable, it's more coherent with the entire library. And so sometimes you can make that choice to not necessarily optimize something, and it's still, even then, it's still a really negligible amount of optimization, really. But it's just not the most optimized solution, but it's nicer for the end user to use.
Yeah.
And sometimes that's more important.
I think that makes sense, definitely. Yeah, so you got to consider whether a certain optimization breaks some convention which you have, like the moxlib one, right, where then it would be confusing for people. Oh, is this a storage or is it a scoreboard? I think that definitely makes sense. Do we want to talk about some optimization tricks which we've learnt over the years of data packing, which just are little things, right? They're not massive overhauls to your code that completely change the way that it works to offer some small thing. They're just little changes you can make in the style that you write your code, which maybe offers a small performance increase, depending on... These won't always be the case, because a lot of stuff depends on context. For example, I seem to remember the moxlib... I think the one I was looking into was it string... I think it was string join, where I would take an array of characters and join it all into a string. And I added... The thing is, it depends on... your whole optimization also depends on the context of what you're doing. So, for example, I think the way I implemented it is it had it had a little check at the beginning, right? The first check was, is the array empty? If it's empty, we basically just return an empty string straight away and don't even bother doing anything else. The second check is, does it only have one item in it, one character or one string in it? If it does, just return that and be done with it. Because both those are cases which could be pretty common depending on the use case, and if so, you don't want to spend 20 or so commands setting up the state and getting everything ready and doing all the checks and only to not use any of it and then just go back to the thing. So I added those two checks in, which makes it faster for those two cases, but it makes it 2 commands slower or something for every other case. And then it's a question of, is that worth it? I think with something like moxlib, you don't know really, because you don't know whether people are going to be feeding it arrays with hundreds of characters in, or 0 to 4, let's say. But the thing with that is, it wasn't an additional check per iteration of the loop. It wasn't an additional check per string in the target array. It was just, 2 additional checks once per time the functions run. So it would really only give a performance difference if that function is being called lots and lots of times. Whereas the commands in the loop, because it's got to iterate over all the items in the array and append it to a string, I try to figure out the most optimal way to do that in the fewest possible commands and the quickest, most succinct way, so that if they do put in an array of 100 things, it only runs 4 commands per thing, 400 commands in total instead of 500 commands, because suddenly the distance between 400 and 402 isn't that much, but the difference between 400 and 500 is a lot bigger. So I put all my effort into optimizing that bit. And the question is, was that trade-off worth it of having those extra 2 commands? I would say probably. But if you're writing a general library like that, it's hard to tell how people are going to use it, what they're going to use it for. But if you're writing a helper function inside your datapack, which is only going to be used in your datapack, you can know exactly what the kind of things are, right? So maybe if I was writing a datapack where I knew that the things I was joining was only going to be 0, 1, or 2 elements long, maybe I wouldn't use the moxlib function. Maybe I'd just write my own one, which just does a check. Is it 0? Return empty. Is it 1? Return that. Is it 2? Just call a macro and append the 2 and return that instead of iterating over it. Because those are more efficient in that case. And if I know that that's always going to be the case, then you can do that. So yeah, a lot of optimization is down to the use case, and sometimes it's harder to optimize things for a general use case, right? So it all depends. But yeah, shall we get on to talking about a couple of tricks that we've learned? So we've already talked about data modify versus data merge and storage versus scoreboards.
But I've got one that's a bit fun.
Yeah, go on.
Okay, so sometimes in a data pack you want a temporary entity that you use in subtick just because entities are nice to perform operations on. There's a couple of benefits to entities. You can set their position and teleport things there. This was a good way of teleporting players from scoreboard values or whatever before macros were around. Entities also perform NBT validation, which can be really useful, for example, for filtering a string, because entities validate their list of tags to not allow duplicates. It means you can filter strings using that, right? So there are a lot of times when you want to use an entity, and usually the entity you'll want to use as a marker because it doesn't load any client-side stuff. It's all server-side, and it's all been optimized to be the one to use for data packs. However, selectors are very, very unoptimized in Minecraft. I don't know what they cooked with selectors, but they didn't cook it right.
Yeah, at
And
E
they are
selectors at least, because they've
at
got a
E
at E
iterates the
selectors.
entire list
Yeah,
of entities.
it has to. There's no other way to do it really.
Yeah.
But yeah,
Well, they could definitely perform indexing and stuff like that, but I feel like they're not
yeah,
doing that.
true.
And
But I
there's a lot
guess
of
I think optimization of
optimizations you
commands
can make.
isn't Mojang's main
Their priority.
priority. Yeah.
No, no, no. That's for sure. But a simple optimization you can make is hard coding the UUID of the entity.
Mm-hmm.
So, and a trick I like to do is I'll place down an armor stand, data get that armor stand. And if you're looking at an entity, you can, like, the tab autocomplete in your command prompt will autocomplete with its hexadecimal UUID.
Because
And then you can easily go into your Minecraft logs and copy out the actual UUID integer array on the entity. And then if you set your marker to use that UUID, and then if you use the hexadecimal representation of the UUID, it selects the entity significantly faster than a selector would. And that can be a massive performance boost to your data pack if you're using a lot of entities that you summon in.
Yeah. That's one that I learnt from you, actually, because before that I would have done summon marker tags new or temp or something like that, and then just use at e tag type equals marker tag equals temp, and then just kill the marker with temp afterwards. But then once I saw you were doing that, I think I saw it in Moxlib, probably, I've started doing that. But I use a pig instead of an armor stand, which I probably should use an armor stand because pigs are really annoying because they walk away and you can't look at them always. It's so annoying. Yeah, and another thing, if you are using a selector, I haven't tested this myself, but I have heard from other people that if you maybe selectors are indexed by entity type somehow, because supposedly if you add a type parameter in selector, so instead of just doing at e tag equals temp, do at e type equals marker tag equals temp. Supposedly that's quite a bit faster, because I guess Minecraft indexes entities by type maybe, so then it only looks at all the marker entities. And I think that's probably a good thing to do.
There's actually a very set order you should list your the fields in the selector in, and if I hopefully I'll remember to link a document of it. I was reading it up. The r/Minecraft commands wiki on Reddit has a whole page about optimizing your selectors. And it's a good read if that's something you're interested in. Obviously, only bother with that once you need it. But when you do need it, you'll be very grateful that it's there. So, But yeah, I think the type, it might be that it's the easiest. It's like the quickest thing for it to compare against. And so it can very quickly discard entities in the list that don't have that type. I'm not sure if it's necessarily indexing them, but I think just in the iteration, that's the easiest thing for it to check is the type.
Yeah, right. That makes sense.
But then again, I don't know. I haven't read the code.
Yeah, because I think definitely the Minecraft commands thing does have a lot of information about optimizing, because there are a lot of people in that community who do spend time researching and testing and benchmarking, which can be helpful in some cases, but not necessary. It's useful, but not necessary, is what I would say.
And it's especially useful for stuff like, Golem script is now something that we're very interested in, because the more performant we can make our language, the more usable it is.
Yeah, for sure.
But obviously, if it just really depends on what data pack you're making. Like, Golem script is then again a pretty obscure use for a data pack. It's like, it is definitely pushing what you're supposed to be doing and able to do with data packs. So not everything needs it. Like, if you're just making a data pack that it's like a what was it? Death swap. That's the
Death
one.
swap, yeah.
If you're just making a death swap minigame, you probably don't really need to worry too much about your use of selectors.
Yeah, that will
And stuff
basically
like
be
that.
negligible, especially
It's
since
going to be
it's only
completely
once
negligible.
every 5 minutes or whatever. But yeah,
Exactly.
I think Golem Script or Code of Copper was probably one of the first data packs I made, which I actually tried to optimize, because before then I had, I don't know, my data pack portfolio is kind of weird because I've had a lot of ideas in the past, or I've started making things, but I haven't actually got things to release a lot of the time because I always struggle with the polish element. I get to the bit where everything's working, and now I just got to make it feel well polished and not and feel balanced and fun to play and everything. And that's the bit I struggle with. But all the data packs I'd released before then were fairly minimal, I would say, and they didn't. Golem Script is very heavy. It runs a lot of commands pretty quickly a lot of the time, and so yeah, it's definitely, that was when I started being more conscious about optimization, I think. Okay, another thing which we've sort of touched on is, I think a big takeaway of this is that selectors are just not very well optimized, but if you do need to use selectors, which you do often, try to run a function with this. Again, this isn't always possible, but if you're saying, okay, you want to check all entities for a certain thing and another thing and another thing, you want to do a series of checks on all entities, right? Every tick. Instead of in your tick function going execute as at e if this, then do that, execute as at e if this, then do that, just do execute as at e, run function, and then call it, I don't know, entity checks or whatever. And then in that, you can just reference those entities as at s, and that is way more performant, because at s is basically no cost at all, because it stores a reference to the entity in the command itself as it's being run. So it just it's just a one lookup thing. It's O of 1, whereas at e is O of n, where n is the number of entities. Although, again, it depends on, I guess, selector order or whatever. So yeah, if you can use at s as much as possible, so if you need to do more than one command as the same set of entities, just do an at s. And maybe you have even all entities with the type cow does this, and pig does this, and sheep does this, and zombie does that, and skeleton does that. Instead of doing an at e type equals for each one in tick, do an as at e, or make a tag for all the ones which are affected. All entities with that tag run another function which just checks at s for those different types, and that can also help your performance a lot. Yeah, I guess predicates are generally faster than direct NBT checks. I don't use predicates if I'm just checking NBT, because I think that's way too overkill, because then you've got to write a predicate for every single NBT check you want to do, and that's just I don't like the idea of that. But if you're doing one consistent check a lot of the time, and you're checking for more than one piece of data, here's the difference. I don't think it's much, or if any, faster for just checking one piece of data. But if you're checking lots of different pieces of data at the same time, then a predicate is faster, because at least what I've heard is it only loads the NBT once. It only reads it once, and from wherever it is, and then it does all the checks there, instead of reading it every single time from the file that's saved or whatever.
Oh, and another optimization on a similar note is if you're doing a lot of NBT checks on a particular entity, it can sometimes be worth caching the entity's NBT in a data storage and checking against that data storage, because reading from the data storage is a lot cheaper, we've found, than reading from an entity over and over again.
And I wonder why that is. I don't know. Maybe
I'm assuming that the entity it deserializes it every single time.
Whereas data storage is,
the data storage must cache the deserialization somewhere.
Right, that makes sense.
That's my guess.
But yeah, that was definitely an optimization we did in Code of Copper, because every tick we were checking a series of data on the golem, right? We were checking their status, which is, whether they need to compile a program or run a program, or whether they're oxidized or waxed or whatever. We were doing a lot of checks on that one NBT. And unfortunately, this doesn't work for all cases, but because we were checking on a marker, everything's inside the data field, and then and you can just do that. You can just copy the whole data field into data storage, do all the checks on that, write back to the data storage instead of writing straight to the entity, and then all after the end of all the checks and all the modifications, then you write the data storage back into the marker entity's data field. Because I don't think you can set, because if you were modifying multiple fields on an entity, you can't just set that. I don't think you can merge an entity's root with the data storage. I'm not sure about that.
I think you can. If you do empty brackets, I think it will select everything.
Maybe you can. I thought I'd tried that before and it wasn't working, but maybe there are certain properties on an entity which aren't writable. Like you can't change an entity's UUID with the Datapack with commands. You can only an entity's UUID is set once it's summoned. So I might have been trying to modify something which was read-only, and that was why. So yeah, entity MBT is slower than storage by quite a significant amount. I'm trying to think what else is there. I mean, advancements are often better than ticking conditions because they run on the internal event system rather than running a check every tick. You can't always do an advancement for things. Not everything has an advancement.
Something I'd just like to add, if you are caching your entity's MBT in a storage, make sure you clean it up afterwards. And this goes for a lot of things in MC function, is that make sure you clean up your temporary storages, because if you have leftover data there and you're like, oh, it'll be fine, it'll just be overwritten next time. Sometimes these data operations can fail for whatever reason, and then you got old data in there, and then it does weird things.
Yeah, if a key isn't present,
debug.
I mean, if you're doing data merge, then obviously if a key isn't present, it won't overwrite it. But yeah, if a certain piece of data doesn't exist, as opposed to being, existing but being an empty object or whatever, it just won't overwrite it. So yeah, you got to make sure you clear them. Probably the best way to do that is just have one storage for everything you want to be temporary, and just data remove. Yeah. And you can't data remove a root part of a storage, so you got to make it, namespace : main, or namespace : private temp dot, and then everything there, and then you can just do one data remove storage namespace private temp, and then just clears it all.
Yeah,
which is something I probably don't do actually. I think I don't clean up my temp storage enough, really. But if I know that something could fail, I do always set it. I don't do it at the end of the tick. I just set it there. So I'd say, okay, if I'm execute storing onto a score, maybe from a data thing which might or might not exist, first I set it to 0, and then I store it so that if it doesn't exist, then just 0 by default or something like that.
Yeah.
So yeah, that's a general thing. That's not optimization. That is just preventing bugs. We had a sort of similar bug like that in Code of Copper recently, right?
Was it
It was Code of Copper because it was the component for the item in place.
Yeah.
And
that was so annoying.
The component, if it was a new pickaxe without any components, then it wouldn't have a damage component and it wouldn't overwrite the damage thing, and therefore it would just consider it broken or have the amount of durability that the previous thing had, which was a whole weird thing. So yeah, make sure you clean up your temp storages either when you're using them or just at the end of the tick. It's probably better to do it at the end of the tick if you can think to do that, because then it's just one operation to clean up everything.
It really just depends how you've got your project set up.
Yeah, it depends on a lot of things.
Another optimization I'll say is that checking block tags is cheaper than checking predicates with a block listed in them. This is something I discovered while writing Moxlib. Because I have a binary search.
Yeah.
Binary search to get a block, because for some reason we still don't have a good way of just getting a block at a coordinates, just knowing the ID of the block at a coordinates.
I know.
You have to do a binary search
It's
to figure it out.
ridiculous.
It's absolutely ridiculous.
Yeah.
And
we always joke about how in Code of Copper, right? This isn't really get block. Get block has seemed to be pretty much consistently fine, but place, every single time, place breaks for whatever reason. And yeah, so place just stops working, and we always make the joke that it's so hard to just place or break a block in Minecraft, a game about blocks. It's way harder than, I don't know, sorting a list or, you know, whatever else we do in Code of Copper, which is pretty crazy, and it's kind of funny.
Yeah, with the exception of that one time, my quicksort implementation has never broken, but it was baffling. I don't know what it could have been. You know, it could have been like cache storage somewhere. It's that maybe. Kind of thing. It's that kind of weird bug.
We can't reliably reproduce it, so it's just going to be a maybe bug until we can find a way, until either it goes away or we figure out what's causing it. And I doubt either.
Well, we haven't seen it in a while.
Yeah, we haven't seen it in a while, so hopefully it's gone now. Maybe it was a bug with that, because we were probably testing it in snapshots. Maybe it was a bug with that snapshot or something.
It could have been a snapshot bug.
And while we're talking about optimization, do we quickly also want to touch on really organization and readability and ease of project management? Because we were going to do an entire episode on this, but we found that we didn't have enough material to cover an episode. But maybe we can just stick it in this one probably, and just talk about a couple of tricks for just organizing your data pack and and making it easier to manage. Yeah.
My first piece of advice, I'm just going to go before we say anything else, don't fear folders. Use folders. Please use folders in your data packs.
Yeah.
They make everything so much easier, so much nicer to organize. Now, obviously, you have to name the folders correctly. Hard problem, etc. But don't be afraid to, if you've got a bunch of functions doing a similar thing, put them all in the same folder. You'll thank yourself, because it'll make it so much easier to manage.
As a general rule, now I don't like it when people have an absolute rule about programming. You know, how have you read clean code before?
I have not, no.
Well, anyway,
you might be able to tell by looking at my code.
Me neither, but there's a book called Clean Code, which is somewhat controversial by some people, but there's something that the guy who wrote it, he says every function should contain no more than 5 or 6 lines of code, which is crazy to me. Like,
interesting.
5 or 6 lines of code is nothing, but and I think sometimes, obviously there is often merit to splitting up your functions into smaller parts, and I agree that occurs in empty function as well, but also a lot of empty function splitting of functions is because there's no blocks. So if you want to check a condition, that's another optimization thing, right? If you're checking a condition more than once, instead of checking it more than once, just run a function and do all the things in there.
My rule of thumb is generally I allow 2 of the same checks to be next to each other. But as soon as I've got a third one, I'm like, I should make this a function.
Yeah.
That's my rule of thumb. Obviously, don't have to follow that. You can go as soon as you got 2. Sure, go for a function. Yeah. You can maybe do 5. I don't know, but probably don't do 5. Probably.
And it depends
just
on.
Split it into a function.
It also depends on what you're checking.
The
right?
type of check.
If you're checking
like
MBT,
a scoreboard check.
If you're checking MBT, don't do 5 of the same MBT checks in a row, because that's not going to help your performance at all. Just write a function for it, right?
Yeah.
But
a scoreboard check, from what I know, is fairly.
Yeah, if you're just checking a scoreboard value, 2 or 3 is probably fine. If it gets to 5 or 6, then maybe just write a function, because it does. The lines do get long in empty function. That's one thing that I know. I always have text wrap on in VS Code, because it's not uncommon to have a line which goes past the default line width and has to wrap. So
I've certainly got some lines that span about 20 lines.
I mean, yeah, for really big
For
things,
registry.
registries, yeah. I am glad that they've added the backslash new line now. It's not the best. I wish they didn't need a backslash. I wish for stuff like NBT, setting NBT, you could just, if it's within brackets, it should just wrap to the next line until it's closed. But I guess the thing is, some of these new features are kind of weird because obviously you can't put new lines in the command prompt in the chat, which makes it sort of weird to implement. I don't know if that has something to do with it. It probably does. It's probably so that they can use one command parsing thing for both the chat and datapacks, and just reading a line in datapacks, they just see, okay, is it backslash before the new line? Okay, just continue on the next line. It's probably to do with that. But it would be nice to just be able to put brackets and then new line without putting a backslash at the end of each line. But anyway, my rule of thumb with functions and splitting up into folders is I like to have maybe a maximum of maybe 5 or so functions in a folder, between 5 and 10, I would say. And then if you get more than that, then maybe consider splitting it up. Or if you have 2 distinct groups of functions in one folder, just split them up into 2 folders if there's more than, say, 2 or 3 of each. I think that makes sense. And also another pattern which we've developed, especially during Code of Copper, is we have an init function, which is essentially the entry point from out of the folder. So anything outside of the folder just calls the init function, and the init function calls all the other internal ones within the folder and does whatever, and then nothing else should touch what else. So often we have init and iterate are common ones in Code of Copper because we do have a lot of iteration over a certain thing, and then other helpers. But you don't take that 5 or 6 functions as an exact rule, because sometimes you just can't. There's no way to split up. I mean, there always is a way, but only do it in a way that makes sense. And make sure, as you said, make sure you name your folders correctly, make sure you name your functions correctly, and your scoreboards and your storages and everything which has a name which you can choose. Make sure to name it so that it's clear what it does. But for example, the Golem script standard library, right? We have there's a lot of standard library functions, and most of those, either they have a folder, because if there's more than one function for that one standard library function, if there's an iterate or other helpers like place has tool and block, for example, we put those in a folder. But there's, I don't know, maybe 10 or 20 functions which just need one empty function file to run, and we just have them all in one folder. And I don't see a problem with that, really. Yeah. We could split them up if we wanted to. We could have, like, function or whatever the folder's called, and then we'll have maths and strings and stuff like that. But I don't really see the point. I think that's fine, honestly. I've looked back at some of my old datapacks because I've had to update them to 1.21 and 1.20.5. In my first datapacks, I didn't use folders, really. Like my Lucky Blocks datapack, I think there was 3 folders, right? There was the main folder, which had all the code for the Lucky Blocks in. That was maybe 20 functions. Then there was the code for the custom Lucky Block crafter. That was in a folder called crafter, and that was maybe another 20 functions. And then there was a folder inside that for all the recipe functions, which did the checks for the recipe, and that depended on how many recipes I had. But yeah, it wasn't particularly easy to navigate. Whereas a tree like that is a lot easier, in my opinion. And also, make sure to prefix your scoreboard variables. Fake players should always be prefixed with a special character so that they don't conflict with real player names. So, $sign is the one that we use in Code of Copper. So
I bet the player named Count is really regretting their decision at this point.
Yeah. Or dot is another one that people use. I mean, pick whichever one you want. Hash is sort of special because it means it doesn't display on the sidebar. I don't like to use hash because one thing I used to do, I pretty much use $sign all the time now, but one thing I used to do is dot for like variables and stuff, and hash for all the stuff which I knew I just wouldn't want to see, like constants, for example. If I have a constant which I know is
Right.
going to be set to 2, I don't really want to. I don't really care to see it on a sidebar saying 2 is equal to 2. Like, yeah, that's fine. I'll just hash that out. But yeah, if you want to have, say, a scoreboard which keeps track of things for players, and you want to set it on the sidebar, and you have one other variable which you don't want to display, you can prefix with a hash, and then it won't show for the players. But for debugging purposes, $sign is nice because then you can see them on the sidebar. You can just display it on a sidebar and see what all the values are, which is pretty useful a lot of the time. That's probably it, right? I don't have any other general tips. Those are the main things, right? Organizing folders and splitting out functions and stuff like that. Do you have any other things?
Well, I don't know if I necessarily have any more tips, but I reckon I do have a little story about optimization that I could tell to maybe finish things out. The story is how I discovered that selectors suck.
Welcome to Storytime with Mathematics.
One of my, I wouldn't say it's my earliest data packs, because those surrounded these things called, I basically made quote-unquote melody blocks, which was a note block that could contain 16 notes at once. So it would play a little song
I remember that.
inside the block. And it was not the best code, but it worked. So that was my first, and then I kind of there was a gap of probably about a year or a couple years before I uploaded my next pack. And I think the next pack I really uploaded before I started doing Datapack jams was one called Speed 255. And this work came about at the time I had started learning a CSS framework called Tailwind CSS.
I remember, yeah, you told me about this. I remember now.
Yeah. So in Tailwind CSS, it has a bunch of classes, CSS classes that it's defined, and you can add them to your HTML elements and it will automatically apply styles. So you can give like font dash bold and then the font will be bold, right? And it makes styling your CSS, like styling your page super fast, right? Now there's arguments to be made that it makes it super ugly as well if you look at the source code, but there is something that there are pros and cons to using Tailwind, I'll say, and I personally quite enjoy using it. So I wanted to do something similar with Minecraft, and at the time I made a lot of maps with my friends where certain things would get effects and stuff like that within radiuses of player and stuff like that. So I made a data pack where you could add a tag to an entity that could be glowing, right? Or it could be speed-2. And then when the entity has that tag, they suddenly have glowing or speed 2, stuff like that.
Did you hard code every single level,
right?
For
So
every
of course
single
I
effect?
hard coded every single. Well, it's the only way of doing it, right?
Yeah.
I hard coded
Without
every
macros,
single
which obviously didn't exist at that point.
selector. I think even with macros, it wouldn't actually work because you have to check every selector on the entity, right? I mean, theoretically, maybe you could parse.
You could, you could technically, use the MBT tag list instead of selectors, but yeah.
But I'm not sure that would be more efficient because I have to run it on every entity.
Yeah.
Right?
Scoreboards would be better. Yeah. Scoreboards would just be better, right?
Scoreboards would be better, and that was something I was going to refactor to, but I kind of gave up on the project.
10.
Yeah. Yep, that would have been smart. Smart mocks would have done that, but no. I wanted to use tags because it was more like Tailwind. Okay, that's a good question. Let me look that up real quick. 2022, so March 30th, 2020, over 2 years. I've grown somewhat as a data pack creator since then. But yeah, I used a lot of selectors, and the pack was not efficient at all. It was you could see the TPS graph go through the roof. And I was even using @s. at S, that many tag selectors. So, like, up to 255 on each of the effects as a tag. Hundreds and hundreds and hundreds of selectors are not efficient.
Yeah.
So the moral of the story is don't use hundreds and hundreds of selectors.
Story time with Max Alex.
I was actually thinking about that. Because I remember you didn't tell me about the unoptimized part, you just told me that you had that idea. And I was thinking it could be fun to do something like that, not the same way, because, clearly that's not particularly efficient. But I was thinking something kind of, not the same, but in a similar vein, it would be like an event system, where people could just, basically you would essentially set up a bunch of advancements mostly, and maybe some ticking commands with scoreboard checks or whatever. And you would just have a bunch of function tags, and people just install your library, stick their functions in whatever tag, like, I don't know, on eat food or something. And then they would just run their function whenever a player eats food, and it would automatically revoke the advancements and everything else. It would just be an API of function tags, essentially. Sort of similar to taglib, which is just a library of hundreds of different block and entity and item tags of various different uses, and it would be like that, but for advancement, sort of. And that could be fun to do at some point. Well, I don't know.
Yeah, it's similar to the Moxlib player module, kind of has that, where you can register your functions in like the on-player died function tag, then it will call that function. So it's something. It's kind of in Moxlib, but it was never fleshed out that much. The player module is kind of possibly the most underdeveloped module. Maybe ignoring Moxlib Experimental, we don't speak of that one.
That still exists, doesn't it?
Of the iceberg.
But it's not updated to 1.21, is it? And all it's got now,
I'm calling it
useful,
basically obsolete.
Is
the state? Is
the Moxlib state void dimension? Which at that point you may as well just create your own one in your own namespace.
Make your own.
But yeah, it was for what was it? String concatenation was the main one that used it.
It was intended for any things that would eventually need to be placed down in the world, and at the time string concatenation needed that, so I felt justified making this, and I was like, I'll extend it with other ones.
Now you can just use macros, so yay yippee.
That's the final optimization. Macros can be a performance cost, they can also be a major performance benefit. So learn to use macros to your advantage. Yeah,
exactly.
Especially if you need to look up something in an array or in an object, a compound, whatever it's called. Macros can often be really good.
Macros are generally faster if you need to loop 5 through
commands.
Something.
Yeah. We figured out, we did some very basic benchmarking. Don't take this as like canon or anything. I don't know how to say it. But we estimate that using a macro is about equivalent to running 5 regular commands. So if you could save 5 commands with the macro, we would say, the macro is probably worth using.
But
right?
that's not exact, because it also depends on the types of commands, right? So
if you're doing 5 @E commands versus a macro. Now, I don't know how you're doing a macro that does the equivalent of 5 @E's, but keep in mind that macros will be a little bit less performant than a regular command, just one-to-one, because it has to parse the macro. Minecraft has to reparse it, basically, and it will cache them.
I think caches last 8 values, maybe. So if you're doing the same macro command over and over again, then it's pretty much 0 cost.
Just the cost of running the first one, really.
Yeah. Indexing an array by a dynamic value is normally you have to iterate over the array and essentially take one item off the start and increment a counter until you get to the amount. With a macro, you just do it in one command, which is faster in 99% of cases. If it's the first element, then it will be slower, but if it's anything after maybe the third, then macros will be faster. So, I think this is a good place to end it. We've talked about what premature optimization is and how it's not worth diving into the deep end and squeeze the most performance out of every single command right at the beginning, but only, there are certain tricks you can do which don't impede your workflow really and just give you a small performance improvement. But for the big things, wait until they're actually needed before you go through and make big changes. Hopefully, after this, you will maybe learn a thing or two about optimizing or organizing data packs. And maybe now you'll be more conscious of spending time at the beginning of your data pack before you even get it working, trying to figure out what is the most optimized way to do it. Because in my opinion, don't do that.